and welcome to the mathleague YouTube channel. The following video was recorded by one of our staff members live at one of our contests.
Hello everyone, Isaac again, and let us go to this team problem here. So let's read it out. Miko creates a sequence starting with a positive whole number of her choice. Then to generate each term, Miko divides the last number in the sequence by 3, rounding down, and she repeatedly does this until the next term is 0, after which she adds all of the terms together to get a total sum. Okay, and let's do this example given. So if she starts with number 10, what we have is that we divide 3. Our next number is 10 over 3, which is going to be like 3 1/3, and we round down in order to get 3. Then we divide 3 by 3 to get 1, and then we divide 1 by 3 to get 0. So our sequence is 10, 3, 1, and then 0, and we just add all of these numbers together to get 14. Okay, and the question asks, how many positive whole numbers less than or equal to 120 could possibly be Miko's total sum? So for example, 14 could be Miko's total sum. Okay, so how would you do this problem other than just trying all starting numbers and seeing what works? Well, what we can do is try to treat this as a function. So we have f of n, where f of n is going to be the sum when starting with n. So what's so special about this function that takes in positive integers and outputs positive integers? Well, what happens if we do f of n plus 1? Well, if we do n plus 1 divided by 3, this result is going to be greater than or equal to the result when we divide n by 3. So if this was our next term, say kind of a sub 1 sorts, and this was like b sub 1 for the sequence for n, then a sub 1 is going to be greater than or equal to b sub 1. Then we take the a sub 1 here and divide it by 3. This result is going to end up being greater than or equal to the corresponding b sub 1 over 3. Because a sub 1 is larger than or equal to b sub 1, when we divide it by 3 and round down, it's always going to be greater than or equal to. So our next term here is going to be greater than or equal to. And so on and so forth. And the total sum, a sub 1 plus a sub 2 plus dot dot dot, is going to be greater than or equal to the sum b sub 1 plus b sub 2 plus dot dot dot. And this is our f of n plus 1 sum, and this is our f of n sum. So what do we know? Well, this sequence here is greater than or equal to this sequence, but we can also note that our starting term is n and n plus 1. So this is going to be n plus 1 plus this sequence here, and this is going to be n plus this sequence here. So it's actually the case that f of n plus 1 is strictly greater than f of n. So this is what we call, over the positive integers, a strictly increasing function. So what does this imply? It implies that whenever we plug in an n here, just any number here, we will get all different results and they will be increasing. So what does this mean? It means that all we need to do now is find the least n such that f of n is greater than 120, and all of the valid numbers will be the f of 1, f of 2, f of 3, all the way up to f of n minus 1. And since this is a strictly increasing function, all of these will be different. So if we do find the least such n such that f of n is greater than 120, the answer will simply be n minus 1. That'll be the number of numbers which could be Miko's total sum. Finally, it's a matter of kind of approximating what n could be valid here. So we can try out some different values here. So just to make it quick, let's go ahead and see what happens with f of 80. That is, we have 80 divided by 3, which rounded down is going to be 26. We have 26 divided by 3 rounded down is 8. Then 8 divided by 3 rounded down is 2. 2 divided by 3 rounded down is 0. So we add all of these together to 116. So that's rather close, but still less than 120. So let's try f of 81 next. So f of 81 is going to be similar, except that this is going to be 81. This is going to be 27, 9, 3, 1, all the powers of 3, it turns out. So we have this sum here, 81 plus 27 plus 9 plus 3 plus 1. And then plus 0. It's going to be 5 more than 116, so that's 121. So f of 80 is equal to 116. F of 81 is equal to 121. 121 is larger than 120, so all of the valid possible sums that could occur will be f of 1, f of 2, f of 3, all the way up to f of 80. So the number of possible numbers that could be Miko's total sum is just 80. And that's it.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.